Okay. Good evening, everyone. Um, well, welcome to today's lightning talk session. So, I hope you're all doing great. Please confirm you can hear me with your favorite emoji. Let me know I'm not talking to myself. Thank you, Brian. Thank you, Excel. Thank you, thank you, thank you, thank you, thank you. Okay, good. So I'm not talking to myself. So today we'll be going into a very interesting topic. Uh, very interesting topic. But beyond the topic itself, I would like to do a very formal and proper introduction of our speaker today. So, uh, our speaker, Mr. Bright Asiwi. Yet, I'm sure those of you that have been following us from the beginning, he has been a very prolific expert teacher and he has been delivering. So he's also a software engineer, a senior one at that. So and he's also a mentor. He's also a mentor in the community as general. So you need anything, can definitely reach out to him. He has debugged as many people that has gone to him. He gets is a prayer answer when you have a bug. You get so he's very good at what he does and he knows how to break things down. And he has written several articles. Yeah, he has written several articles that are very much a blessing to every developer and Java developer out there. Let's go and read his article, check his link to check his medium. Okay. So the topic today we have is Java Generics Demystified. So I know some of us might have used it, some of them might not have used it. It might look like something something complicated, but today ready to be woke regarding that aspect. So I will welcome, but before Mr. Toshi could take Mr. Boy takes, I think our the piano and the madam of NAIJA-JUG want to give us a little bit of speech. So Madam Gloria, please have the floor. Then Mr. Bright can take over. Madam Gloria.
Good evening, everyone. Please confirm if you can hear me. Can anyone hear me? Okay, so it's just more like thank you very much. It's just more like a brief announcement. Though. I know I mentioned earlier last week Saturday that our next TSA is going to be this coming Saturday. But I just want to inform you that that will not be holding because this coming Saturday we are having our monthly section. So just in case you did not see the flyer for the DSA. So that's a brief information I want to give to the house. And I just want to welcome everyone today as well. Just on Lane, and Lane. Thank you very much.
Thank you very much for that clarity. So this next coming Saturday is monthly session, not our DSA. Monthly session. So prepare your mind. The monthly session is once in a month, 12 times in a year, and it's going to be very powerful. We're talking about tech entrepreneurship. You all go out, I did a breakdown. Tech is leading the world, tech is evolving. As much as you want to believe that, the people that are dominating the tech space that are actually making the money, they're not even tech inclined. They are just business people. So it means uh, 10% of the tech that is taken everywhere is not run by the tech people. So we need to open our head up to actually dominating what we claim is ours. So let's open our paper out for that particular session. So Mr. Bright, over to you.
Hi, good evening, everyone. Can you hear me?
Good evening, sir.
All right, thank you, Samuel. Yeah, thank you. Read on, yeah. Okay, so let's get started. I'll quickly share my screen. So my network is not so good. So if at any point you stopped, hearing me, you just find a way to, to let me know. Why is it not? Okay, show my screen anyway. All right, so I will enter into slideshow from beginning. Yeah, so our topic for today is Java Generics Demystified, right? So you may ask, what is generics, right? What is generics? So let's go over to the next slide. Yeah, and this is like the table of content that we'll try to cover, even if we don't cover it all, but we'll try to cover it up. So we'll look into understanding generics, word without generics defines bounded types, wildcard types, lower bounded wildcard types, upper bounded wildcard types, type erasure, and conclusion. All right, so next slide. All right, so let's have a bit intro into understanding generics. So generics allows us to write code that can safely work with multiple types without repeating yourself. So I believe we all know about the principle of keeping your code dry, right? To write a dry code, that is, you don't need to repeat and repeat yourself. So generics can safely help us to achieve that. The key concept of generics is type abstraction and compile time type safety. So I believe we all know what is type abstraction and compile time type safety. So I will just explain a bit on compile time type safety. You know that we have like runtime, things that happen at runtime, and things that happen during compile. So compile is like during development. So generics can give you that real time compile time check, right? So in a nutshell, generics lets you write flexible, reusable code that works with any type while still being type safe. Yeah. So we'll build on this as we go forward. So I need to fly so that we can steam it up. A word without generics. We'll be asking like, since generics bring type safety to the table, right? Compile time, type safety, and type abstraction. What will word be like without generics? Yeah, so without generics, programming will be repetitive, error prone, and harder to maintain. Developers will need to separate classes. So developers will need, separate classes and method for each data type, leading to bloated code. In simple terms, your code will not be dry. You have to repeat and repeat yourself. And we'll see how that plays out. Yeah, we'll see it in this demo. Code would be less safe, less reusable, and far more difficult to manage. Generics solve this by allowing flexibility in types while enforcing safety at compile time, making program cleaner, safer, and more maintainable. Yeah, so before I move to the next slide, I just want to, ping the team. So can you still hear me? Please, you can speak up, Sam.
Yeah, we can hear you. We can hear you.
Okay. Yeah, thank you, because my network is very, very poor, so I don't want to be talking to myself. All right, so we'll go into the first lab, a world without generics. So in this particular lab, we'll explore what it looks like, writing code without generics. So to make everything fast, we'll not be typing the code herein. We'll just demo the code, right? So that it's more like a thought-provoking demo, right? So it's not like a coding section. All right, so I have this Marvin project, just a Marvin project. Let's kind of look through it. I will clean up all this stuff so that we know where we are. So I won't. So now this is just a simple Marvin project, not a Spring Boot project, just a simple Marvin project, right? Good. And the name is JUG's Java User Group Generic. That is JUG, right? So now we'll be starting with the first folder or the first package, which is without generics. Let us see what it looks like, to write a code without generics. So look at this. We have like a data service, right? And we want to write a code that will return a string, return an integer, return a double, right? You want to return different data types. So without generics, you end up duplicating your code. You can see we have get data as string, get data as integer, get data as double. This is what duplication. It is not a dry code, right? Good. Now you may say, okay, I can use an object and cast it. Now let us see what it looks like, to use an object and, to cast it. So let us say we have like this get data that takes in an object. Obviously, everything in Java is an object, almost everything here. So let us say it takes in a value and it does some operations and it returns that value. Now, for you to ensure that you don't run into some type casting or type issue, you need to what? Cast. You need to check instance of string, instance of number. That is dirty code. That is a whole lot. So this is like a sneak peek, yeah, good, into what it looks like without Java generics. You repeat yourself a whole lot. Now let's proceed. And also, please, if you have any question in the code, also ask, okay? But let us fly. Now, let's enter the generics main. Can you still hear me, Sam?
Yes, we can hear you. We can hear you.
Okay, thank you. Because I'll be pinging you, back and forth so that I know where I am. All right. So generics allows you to define classes, interface, or method with type parameters, so they can work with any data type while still maintaining type safety. Good. When defining generics, you use placeholders. You may have, I believe we have all seen this, but for the genius among us, usually, a single uppercase letter, like you see things like T, E, K, V, things like this. You see it in codes in so many places, especially in packages, packages that you import and reuse and use, right? So you tend to see a lot of these symbols, yeah. So they represent types which will be specified later. So we understand this TK, they're not mysterious, It's your point of the talk to demystify it. So yeah, so sit back and let's move. Yeah. Let's log into generic method. So a generic method is a method that declares its own type parameter, allowing it to work with different types while maintaining type safety. Unlike regular methods, the type is determined at the time the method is called, that is in compile time, rather than being fixed beforehand. So for now, don't hang on this long definition. This is just formalities, right? Let us see practical how this generic method works. It's actually a simple thing, right? So we'll go over to the next folder with generics, all right? So I will go to generic method demo. So I will click on this. Good. Now remember, we defined previously a get data type, right? Get data method, and we passed in an object, and we had to cast, right? Now look at this method, just a one-liner, right? You define a get data and you pass in T as the value. Then you come here. Can you see this? Will I say angle bracket? But you can see this. Is it less than, greater than, something like that? So now this T you see here is a type definition, right? This is a type definition. Yeah. Then this other T you see here is a return type. So it means that once I call this get data with a type of T, I should return a response of type T, and I've defined what my type T is, right? So this is just a one-liner, and we'll see. Now look at this. In this get data, I can pass in a string, and I'll return a string. I can pass in a boolean, I'll return a boolean, right? I can even pass in double, right? Good. But now let us look into the compile time help. For example, look at this one I commented. Let me bring it back. You can see I said, get data, and I passed in a string, right? And I'm expecting a double. You can see the compile time here. It's telling me real time that, no instance of type variable exists. So the string confirm, all these ones, you just see that incompatible bound, right? Can you still hear me, Sam?
Yes, we can hear you, Mr. Barks.
All right. All right. So this is the compile time here, right? And look at this. Let's just dwell on this a bit. this is, look at it, you see the type abstraction. For example, when you define this method, you didn't had code beforehand that it is a string, or it's a double, or it's a boolean, or is a custom data type. You didn't, specify beforehand. You just defined it. So this is what your type abstraction, right? And this one helps us, you can see the compile time help, right? So compile time type safety. So you cannot pass in a string and you expect a double, given how we have defined it, because we are expecting to return a value, and value is of type T. So I'll comment this back and I will move on. So I can also run this code. Let's quickly run this code, and yeah, you get the code letter for your own use. So I'm trying to build it. So let's give it just a little while. So you can see it has returned name is bright, is valid, that is boolean, right? This is valid, yeah. So this is just it, yeah. So let's move on. Let's move on. All right. So we have explained this generic method and we have seen the lab, right? If you have any question, you can ask concerning the lab. But if there's no question, I'll move on to generic class. So a generic class is a class that has one or more type parameter, allowing it to operate on different data types. Okay, somebody raised hand. Please, can you go ahead?
Yeah, good evening, Mr. Bright. So the generic method, can it be used for our getters and setters?
I didn't get you. Please, Sam, can you echo it better?
Okay, he said, can you hear me? Hello. Hello? Okay. Mr. Bright, can you hear me?
Yeah, my network, went bad.
Okay. So what he was asking, what he asked was, he asked if you can use generics for getters and setters. Is that right, Ridwan?
Okay, if I can use generic for getters and setters, all right. Okay, definitely you can, right? And let me check this one. I think we have it defined here, right? So yeah, you can use it in getters and setters, and we'll see it in the next one, please. Okay. Now you good, Ridwan?
Yeah, I'm good, sir.
Can you hear me? Are we good?
Yes, I can hear you.
All right, thank you. So you can use generics in getters and setters, okay? Naturally, it also shines there. It also shines there. All right, so we said instead of writing multiple versions of a class for different types, you write one class that works for all types, right? Like before, don't worry about the long grammar. There's always a demo session to explain it. So let us go to the next practical lab, which is what generic class. So for the purpose of this lesson, I use something that we tend to use every day. Like for those that work, I believe all of us work as back-end developers, right? And we tend to return API responses, right? And I believe we are all familiar with this. So you have an API response, and your API response can return multiple types, can return different types, right? So what do? You define a simple class that you can just pass in whatever data type you want, and it will return it. So here I defined an API response that taking a type T, and this data is of type T, and this status is an enum, right? So this is an enum. I just defined an enum here, failed and success. All right, so that is it. And now this is the constructor of the API response, and this is like your getters, right? You can see we'll still use like a generic in the getter, right? And yeah, though I didn't make setters because there's a controller. Sorry, there is a constructor. Yeah, I can just pass in what you want. So it's more of a safe save class. Yeah. So I will just run this. Here I want to return a response of type string, and here a response of, type list of integers. So I'll just quickly run this for completion's sake. Yeah, but when you get the code, you can easily. So yeah, I just logged, response data, blah blah blah. This one success, and the data is Apple. And yeah, you can go over this later when you have the source code. But this is just a brief, demo on how you can declare generic class. You can see I don't need to write different class for string, different class for list of integers, different class of list of custom classes. No, just one definition, and my code is dry. All right, so let's move on. I don't know if there's any question. Can you see hear me, Sam?
Yes, very clear, sir.
All right, thank you. Let's move on. Let's move over to generic interface. This one, I know we use it almost all day. So a generic interface is an interface that defines one or more type parameter, allowing the interface to work with different types while maintaining type safety. Yeah, still almost same thing with the other types we have defined so far. You write one and you reuse. So yeah, I won't go deep into reading all this. Yeah, we'll see it in practical. All right, so in this practical lab, we'll explore how to define a generic interface, and yeah, let's go far to it. So in this one, I modeled something that we kind of use on a daily. I modeled like a repository. Yeah, so mind you, this is not like a Spring JPA project, right? It's just a normal Java mapping project. So this is just a demo, right? So now let us say I'm defining a repository. Let us say I'm building a multi-level application that we have user repository, then so many, repositories, right? So what I do here is I just define a repository that takes in the, the entity type of T and the UUID type, that is the ID type of U, right? So it has some methods like save, it takes in the entity, find by ID, it takes in the ID type, and find all, it returns a list of this type. So here I have implemented it in user repository, and don't bother about this, subtleties here. This is just me defining a database, to just, simulate this, dependency injection. But just a quick sneak. So this database is just something that, it accepts puts, get, and key sets, right? Yeah, so the database just for, normal dependency injection, right? So here I pass in the database and the definition, and here I call the save, and I, implemented the find by ID and the find all. And this is the main method here. Here I, created an in-memory database. This in-memory database is just something that implements type database, right? For, it's still where we are, still just to keep our code dry and reusable. I believe we all know the concept of dependency injection. So it's not what I need to go deep into this demo. All right, so it's basically a user repository that it saves a user, it finds by ID, it finds all. So let me quickly run this code and let us see, right? So while it's still trying to run, I just want to show you that, in your generics, right, you don't have to pass in just one type. You can see here, we took in multiple types, right? There's no limit to the type you can pass in, actually. So our code ran and it says Bright. It's got the ID of Bright and the details of Bright, and it also got our find all and gave us a size of 1. So I won't go deep to explain this. Once we get the source code, is very, very straightforward, right? I don't know if there's any question. Sam, please, can you hear me?
100%, sir. Can you hear you?
All right, thank you. So basically, this is us, using generics to keep our code dry, right? For generic interface, straightforward, right? So if there's no question, let's write on. All right, so let's go over to the next slide. Advanced generics. Yeah. So in this section, we'll explore some advanced topics in generics like bounded type, wildcards, lower bounded types, and upper bounded wildcard, right? So I believe we've heard about wildcard, right? We'll just take a brief look into it, more of a thought-provoking look, something that can lead you to go explore it better. All right, so bounded type. Bounded type in generics allow you to restrict the type that a type parameter can accept. Restriction, good. So bounded, in a real life, once something is bounded, you are restricted, right? So here you are trying to use generics to restrict a given type. You want to set a boundary. Now, I'm defining a generics that can take in just integers and numbers, right? It won't take in. You can see in these other ones that we define, right? It can take in anything. You can pass in any data type, right? But now you want to define a generics that is bounded. It is, strictly within a bound. So instead of letting the generics to accept any type, you specify upper or lower bounds to make your code more precise and type safe, right? So we'll see how we can, utilize the bounded type. All right, so I prepared a little demo for bounded type. Let me enter here. All right, so for this bounded type demo, I prepared a calculator. Now, why did I use a calculator? A calculator, for example, your Casio calculator can only take in strings. Let's assume, can only take in numbers, right? I know that number is like a very, very broad class. Integer is number, double is number, big decimal is number, anything can be, if you even check the number class, you can see it's an abstract class and it has so many things that won't really go into, right? But it's just to, take your mind to it. So a calculator takes in just numbers, right? So we have defined a calculator class and we say that this calculator will take in a type that extends number. And previously we learned about inheritance, and we'll say that you use extend for inheritance, right? So here is saying that I'm only going to accept any type that is a subtype of number or number itself, right? Okay, so now you have limited what this calculator can take to only numbers. It can't take in strings. It can only take in numbers. So here is a constructor more like to initialize the list of numbers I want to work on. And I defined a sum method, I defined a multiply method. I won't go into these methods, right? Since it's not the purpose of the demo. I defined a subtract method, much like trying to model a normal calculator. I defined a divide method, and here I have a main, right? That is the main entry point. And I defined a list of numbers. You can see there is 6, there is 8.0, there is 9, there is 0.9. And if I try to add in a string here, you can see I have a compile time error, right? A compile time type check. So yeah, this has been restricted to passing this list of values to the calculator. And we run this, right? We run this. So let me try to quickly run this method. And let's move on. Yeah, we have barely 27 minutes. All right, so you can see our calculator, it ran the sum, the multiply, the subtract, the divide. So once you get the source code, you can look into it. And if there's any bug in it, you ask questions, or can always debug it together. I don't know if there's any question on bounded type. All right, Sam, can you hear me?
Hundred percent, 100%, Sam.
Okay,
100%.
great, thanks. 100%. Yeah, sorry, I'll be pinging you back and forth, please. Yeah. All right, let's go into, we've looked into the bounded type, which is a normal bounded type that is not a wildcard. Please don't get it twisted, okay? We have bounded type and we have wildcard, and we have lower bounded wildcard and upper bounded wildcard, right? So we'll look into this, okay? But don't confuse wildcard with bounded type, right? So yeah, bounded type is just about, specifying the boundary, you can't go beyond this, you can't go below this. And yeah, we've looked into this demo, this lab 5, and let us go into wildcard. I believe we've all seen this question mark. At some point, this question mark used to terrify me in Java, honestly, right? But as time went on, I actually got to understand what the wildcard is doing and all the goodness it brings into Java. Yeah, so a wildcard type in Java generics is represented by the question mark. This will sit in the code lab. It is used when the exact type is unknown or not important, but you still want to work with generic type in a safe and flexible manner. So for example, you don't know what type that's, for example, you are reading something from a package or from some cache, right? And you don't know specifically if it is, an integer or a double or a big decimal, but you just know that, it is a number, right? So for some reasons, you don't know the exact type. So this white card comes to the rescue, just like how Dora, comes to the rescue in those cartoons. All right, so let us look into wildcard type and the definition, right? So, for example, let us say we have this print list, right? And there is this in Java, I can't really place the exact name now, something covariant and invariant, something like that, but you should definitely, look into that. So if you have a list of objects, you know that, list of integer is not a subclass of list of objects, even if list of integer is an object, right? And list of object is still an object, right? But you can't pass in list of integers for objects. You can also pass in list of doubles for objects, right? Even if that list of objects. So how can you, get around this? You use, a list of wildcard, right? We'll see a code demo, to demo this. And yeah. So let me quickly have a code demo, even if I didn't put the lab here. So let me check wildcard. So I have a package here called wildcard, and I have wildcard intro demo. Good. So here we have, print list, right? So let us say this now, this print list, right? Let us say I'm passing, a list of strings. You can see there is a compile time error, right? Because you are expecting a list of objects and you're passing a list of strings, even if they're both objects, right? So you can't do this. You definitely can't do it. But let's say for some reasons you need to go ahead and work and you want to do it in a safe, we want to prevent casting and a lot of other, too many code. How do you do that? I have like something here, print list with wildcard. I pass in a list of wildcard values, right? So this can accept basically anything, right? So I define the string value and I passed it in. You can see there's no compilation error. And one thing is that if you are reading this, though I didn't go deeper here, if you're reading this, you read it as an object, right? So, all right, so let's run this. So our code runs, I think, what did I even, okay, I ran a different thing, sorry. So yeah, so our code runner, you can see the value I passed in. I passed in a list of bright, right? But I just want to get your attention to something, right? Because you may face this later in the future. Let us say now, you can see there's a compilation error, right? Let us say I pass in a list of like this, a list of like so, and I pass in bright. You can see the compilation error is gone. And you may ask yourself, why? I passed in a list of strings, it gave me error, and I passed in, just a list of direct, and it happened. So this thing is some of the subtleties of Java and your IDE being able to recognize that, you actually mean list of objects, and it casts it for you into list of objects, and you are good to go, right? But you can explore deeper into this, yeah. So, but it's just to bring your mind to it, because you may face it later and you ask, I defined a list of objects and I'm passing in a list of strings, and it's going. So these are some of the subtleties. Okay. All right. Can you see hear me, Sam? Can you see hear me?
Yes, 100%. We can hear you.
All right. Thank you. Let's move on. Let's move on. All right, so let's go to the next type, which is the bounded lower bound wildcard. So you may have seen something like this, wildcard super T, and it is lower type. Now let's try to understand this. why is it, this question mark super T, and why is it lower? Now, let me just explain how it reads, right? It says that it should accept anything that is of type T, and type T should be a subtype of it. I don't know if that is clear, but now let's go again. It says, taking anything that is of type T and is, super class or super type. For example, if I pass here as integer, it will take in only integer. It will not take in double. It will not take in big decimal, because big decimal is not a super type of T, right? So it can only take in, it can only accept, integer and the super types of integer, which is a number and object, right? So the main purpose of a lower bound wildcard is to allow safe insertion, writing of elements into generic. So if you actually, now there is this thing called the PECS, producer extends consumer super, right? So, and you may get confused, consumer is not reading, but in this scenario, consumer is actually the one writing into a given list, right? So this is your consumer super, right? So, but let's not dwell on this and let's move on. For example, we have lists of wildcards, super, integer. It means that the lowest data type that can be inserted into this list is an integer, and then the super types of like number and object. But mind you, there's a clause to it. List of wildcard super integer is not a super type of list of wildcard super number, right? So if you are passing list of numbers to this, it won't also work, right? But we'll see how you can do that, right? Basically, just see it as, you use it for, for writing into a list. So this example may not make too much sense, right? Because I couldn't find like a very, very simple example to explain it, right? So I just, I put this up together, something that can easily understand. So I have this, list, right? It takes in wildcard super integer, and this is a constructor. So this, you can see, this is your reading of value. If you want to read value, you take it as an object, right? Because this type cannot, you won't say it's a double, you won't say it's a number, it is actually an object, because it reads that anything that's an integer or the super class of integer, right? So you read as an object. But now look at the writing here. Let me expand this a bit. So for example, here I have this list of integer, list of number, and list of this, right? So I can safely pass this into this wildcard class, because integer, number is a super type of integer, right? And the object is a super type. I can't pass in like list of doubles, because double is not a super type of integer that I defined here. All right, so let's move on. Can you still hear me?
100%, Mr. Bird.
All right, so let's move on, and we've done this, and this one I will just skim through this one so that we can finish up early. So we have the upper bound wildcard. So here is wildcard extends T. That one is super. So this one means that T can take in what will I say? It means that it can take in subtypes, right? That one said it can only take in super types. So this can take in the subtypes, right? So upper bounded wildcard are used when you want to read value from a generic structure safely. You can see that the one that is super is used for writing, and the one that is extends is used for reading. So that is your producer. What is the extends? That is PE. We have PECS, producer extends consumer super. So this is your producer extends. So it is used for reading, and it may confuse what you already know in queues. Producer is one that is sending out while the consumer is reading. But here is a bit tricky, right? But it's just a thought-provoking stuff for you to, to go deep into it. All right, so I won't spend too much time here. This allows you to safely read from a list containing different subtypes of number. You can see here, so wildcard extends number. So you can read, you can see, you can pass in integer, you can pass in a double, you can pass in anything that is a subtype of number, right? So let's not dwell much into this. And this is an exercise for you. So you can do this later once you get this slide. You can do this later. Go through how you can use, this upper bounded wildcard to like model, some classes and use them and read from it. All right, so let's go into the last part, which is type erasure. So you may ask, does, generics survive? Does, generics survive throughout the lifetime of your app? The simple answer is no. Generics doesn't survive throughout, the lifetime of your app. So a generic type information exists only at compile time and it is removed at runtime. Java uses generics to check the type safety while compiling, but does not keep the generic type details once it is running. So your generic type, those T and those V and those U you define, doesn't survive compile time. So once your application is done compiling, we'll see what happens. Actually, we'll see what happens. Yeah. So for example, you define this, a list of T, right? Good. So once this has compiled finish, it will take away this T and replace it with an object. You can see after compilation, it becomes lists without this type. So this is just what a list of objects. So if you define a T, right, it will replace it with an object, right? But now what happens if you define a bounded type? We'll see. So you can see is now reading it as an object, no longer as, the specific type. So at runtime, Java doesn't know what type you passed in. It only knows it at compile time. So once it is done compiling, it removes all your T and replaces them with objects. And this is so for backward compatibility, because lot of Java versions have been written before this generic. I can't really tell the Java version that has generics in it. Yeah, but this is so that what has been will be backward compatible. When you are developing a software and there are features that you need to add, you want to make it backward compatible so that nothing breaks. All right, so let us say you have a bounded type. What happens? Let us say the T extends number. You can see after it's done compiling, it will replace this T with the bounded type, which is this number, right? It will be reading as a number, no longer as an object because it's a bounded type. So it will always take the bound in it after compilation. Okay, so you can read as a number. Yeah, so are we still together? Sam, are you there?
Yeah, we're there, 100%.
All right, thank you. And conclusion. Yeah, sorry, it's a long one. So generics makes Java code type safe, flexible, and reusable, allowing classes, methods, and interfaces to work with different types safely. We've seen this with the different labs, even if those labs are not so hands-on, right? But just to thought provoke us to let us see what is there, or to remind us what is there, to remind us and also to thought provoke us, to see ways that we can actually use, generics to keep our code dry. Very, very important, as we grow in this, software development journey, it is very, very essential that, we find ways to make things easier, to make life easier for us, right? You don't need to write code, yeah? You just need to, make it simple, make it easy. And one way you can make your code easy for you is using generics. But there's a clause there. If you use generics anyhow, your code will also be dirty, right? So there's always trade-off in everything you are doing, right? But I think the benefit of generics kind of outweighs it. It's not even kind of, it outweighs the downside. So for further reading, explore PEX. I mentioned PEX, right, which is the producer extends consumer super. So this will help you solidify your knowledge and will help you understand when to use the super and when to use the extends in a bounded type. Yeah. So that is it. That is my demo on Java Generics Demystified. I don't know if it has been demystified actually. So yeah, that is it. Thank you, Sam.
Thank you very much, Mr. Bright. Thank you very much for that one. My hands have been raised for the past 2 hours. So thank you very much. That's a very powerful one. Before I ask my question,
Yeah.
Before I ask my question, who has questions? Who has any question to ask before I ask my question? Can we hear me? Can we hear me? Okay,
Yeah,
good, good.
I hear you. Can hear you.
Okay, good. Okay, so Oscar Nwanzi and Ibu B. Okay, let's start with Oscar. Oscar, you can go. Oscar, you can ask your question.
Yeah, can you hear me?
Yes, we can hear you, Oscar.
Yeah, go ahead.
Okay, all right. Yeah, hi, good evening, Bright. First of all, thank you for that session. I didn't enter from the beginning, I entered from the middle, but I got a basic gist of what you were talking about from when you were describing the generic types. Generics aren't really my strong suit in software engineering, which is what I was like really looking forward to this course. So I have a question to ask. When you were sharing your slides, yeah, like I said, I joined in the middle when explaining, let's say, upper bounded and lower bounded. Basically, the wildcard super T and wildcard extents. So when you were describing them, yeah, this is my question. Before you got to the conclusion slideshow that you put up, you gave a summary of an example where you showed the wildcard extends T and it was using a number type. And you said that in essence, that's you creating an array list and whatever is being inserted is a number type. So I wanted to ask, because like I said, I didn't join from the beginning, if you can please refresh my memory. When you were describing the super T and the extend T, to me in my head, the super T seemed like someone using the abstract keyword, and then the extend T is akin to someone using the extend keyword, like when creating a class, like let's say for a service implementation that wants to inherit something. So for me now, when you showed that example using the extend T, it seemed like it was bounded to that number type. When you were explaining it to me, it seemed like it is not bounded by that type, but it can use that type, maybe a number and something else. So I just wanted clarity on that just to be sure. I don't know if you got what I was asking. So yeah.
Yeah, thank you, Oscar. So I got, a good part of what you said. So you kind of emphasize on the upper bounded type, right? Let us say the white card, extends, T, right?
Yeah. The wildcard extends T.
Okay,
That
great.
last
All
one
right,
you
great.
explained before the conclusion.
Great. So I will just shed a little bit of a light in it. So I believe you may have come across the acronym PECS, Producer Extends Consumer Super. All right. So that extends, for example, we have, we have list of, white card extends number. It means that it can only read from, it can only, read from any list that is a number or the subtype of a number. So now, though the name upper bound and lower bounds may be confusing, but now see it this way: extends upper bound. It means that from this number, from this type downwards, upper from this type downwards, right? So it means you can read from a list of integers, a list of numbers, a list of doubles, a list of big decimal. So basically, that white card extends T is for reading, right? You cannot safely write into it. Okay, you can't safely, write into it. Yeah, because it doesn't, for certainty know that okay, you are writing an integer or double or big decimal. It's just basically for reading, right? So I know that this explanation may not do much justice to it. So if there's anyone on the call that wants to add anything, yeah, you can go ahead. But for now, this is just what I can wrap my head around for you. Thanks, Oscar.
Okay. Is there somebody that wants to clarify? Or I don't know. Is Mr. Oscar, you good with that explanation?
I'm like, I get the angle you're coming from, but maybe I'll do research myself as well into what you're saying. I'm not fully conversant with PECS, so I actually learned a great deal from this myself. So I know that I have to read up more on that myself. Um, I get what you're saying as per reading and writing. You're saying that one is most preferably for like read only, no writing. And I'm having some issues in my head, but I'll definitely read up more on it so that I can get clearer. But thank you very much, too.
Yeah, thank you, Oscar. It's just more of a thought-provoking section so that we can know about these things and we'll dive deeper to get good at it, right? Yeah.
Okay. Thank you very much. Ibubi, Ibubi, you can ask your question.
All right. Sorry. Good evening, everyone. My question
Good
is,
evening.
for the sake of clarification, I just wanted to be sure, like, what was the major change you see that happened? What's the major change in generics that happened between the Java versions? Is it that a newer version doesn't use type erasure anymore? So I just want to be clarified.
Okay, thank you, Ube. So I will try to, to answer that. The whole concept of type erasure is not about newer. Okay, I would say it's more about older. Now it's more like a backward compatibility stuff. There's always improvement, right? Now we are currently in Java 22 or thereabout, or 24, right? But there have been prior, versions that doesn't even know what is generics. As at the time when you have to cast almost everything you are doing. So this type erasure is just to ensure that once Java compiles and is running, it is also compatible with older versions, right? So if not, things will start breaking. Okay, if not, things, for example, now you have a code base that is a very, very old code base, and we are conversant with this because the companies using Java are mostly old kind of companies, and their code base are a bit old, right? So you always run into, okay, the version is older, and you need to work on something and extend it to newer versions. So this type erasure, I'm not saying that this is exactly why, but this type erasure is just to ensure that things don't break. There is a backward, compatibility. Yeah, so that is just a tip, right? If somebody that wants to add more can actually expand better on this. Thanks.
Okay. Anybody on that? Ibubi, are you good, or you
Yeah,
do research?
I am very clear on it now. Thank you, Mr.
Oh,
Bright.
okay. Okay. Balogun. Balogun, you have a question. Oh, so is it Balogun first? Mr. Toshiku, sorry, you asked your question. I think you answered well earlier. But Balogun, please, you can go ahead.
Okay, happy evening, everyone. I actually don't want to ask a question. I actually want to speak a little bit about the upper bound question that was asked earlier.
Okay,
So
okay,
based
okay, good.
based on how I understand it, from that lecture, you can see that it is question mark extends T. All right. So I don't know if you are familiar with wrapper classes in Java. So in Java, when we talk about wrapper classes, there is a particular class called number, which is an abstract class. And then there are some concrete classes that actually extends from that class, which are the double, the long, the integer, and so on and so forth. You will actually understand those if you understand wrapper classes. So that question mark extends T. Let us assume that T is replaced with number abstract class. So what it means is that particular type should be any class which can be maybe the integer class or the double class or the number class itself. So as long as it is that class or any class that extends number, then it will compile successfully. So I don't know if that explanation actually makes sense for the upper bound, basically.
Yep.
Thank you.
Yep. Thanks.
Okay, thank you, Balogun. I mean, Oscar, does that clarify a bit?
Yeah, hi, Balogun. Yeah, thanks very much for that. In a sense, it kind of does. As he mentioned it being a wrapper function, I guess that kind of also explains how someone can actually create their own helper wrapper functions and then extend or utilize it and make sure it's bound. So yeah, that really makes sense. So thank you for that.
Okay, thank you very much. Mr. Tochuku, you can ask your question now.
Yeah, Mr. Bright, thank you very much for this wonderful section and the topic you brought. It's not actually like a question, just like the reason why I most times don't kind of want to use generics. So I want to know if other people also feel the same. You understand? I feel that generics enables tight coupling. Like using generics kind of make your code to be tightly coupled to a particular class or a particular method. Whereas we are looking at something that should be decoupled. We are looking at decoupled applications. So I don't know if anyone can, Mr. Bright can throw more light on that, the relationship on decoupling and tight coupling using generics.
Okay, thank you, Toshko, for that. It's actually, thought provoking, And if we kind of look it with one eye, we may say, this generics is somehow. But let us also look it with another eye. The whole concept of generics is, let us abstract, let us write once and use it for any type. You get, and if you look at that, you see that it kind of aligns with, the concept of Java. I won't say this is definite, right? But Java is all about, write once and run anywhere. But I'm not really saying that, that is the whole concept of generics. But the deep concept is, type abstraction. For example, you saw the get data, method that we define. You can see that we can call it with number, we can call it with string, we can call it with any data type at all. You get, so it ensures that you don't repeat yourself, and also you are type safe. You can see that when we pass in a string and we are expecting a double, it gave us that compile time exception, right? So not really exception, but compile time, linting error, all those stuff. Yeah, so that is if you take a deeper look into, you see that the actual concept of generics is loose coupling. So our get data method is not coupled tightly to string or to integer or to any data type. It is open for anybody to use. It's much like a contract, like how you have your interface, where you define a contract and you implement as you want, but you stick to that given contract. So I can understand if you say, okay, that's sticking to it is a tight coupling, but if you look deep into it, you see that is not really tight, tight coupling per se. It's much like a guardrail, to ensure that you stick. You have garbage in, garbage out, something like that. But I'm not saying it is garbage in, garbage out. Yeah, thank you.
Okay, thank you very much, Mr. Bright, for that one. Tochuku, are you clear on that?
Yes, I'm clear on that. When it comes to like in the API responses, where we have to make use of that generic class for to return the responses, and like every other classes have to depend on that particular generic class. You understand? So I'm kind of seeing a tight coupling there. Like when let's assume your application grows larger, and I don't know if other services will also have to leverage on that same response class to return their response.
Okay, is there a question? Or
Oh, can you hear me? Can you hear me?
yeah, we can hear you.
Yeah, so I'm
I
trying
can hear
to
you.
to explain to Tochku. Now look at it this way, right? I believe you do use Maven, you do publish your packages to GitHub packages, right? Good. Now, let us say as your application is growing, you can actually extract. I know that we've talked about this topic extensively in our group, in our, JUGS group, right? You can actually extract this, API response into a different Maven project, and you publish it to your GitHub packages, and you take the package, artifact ID and all those, what have you, and you put it into the using method, that is the dependent method, or sorry, dependent project, and you use. So you can see it is just open. And when you talk about tight coupling in that essence, there are ways around that. Publish, extract it into a different project, publish to Maven, and reuse. And that is what most companies use, right? You can see that they have like a DTO packages, or a response packages, and these live in different repositories. All they just do is publish to GitHub package, which is free of charge, right? And you put it in different projects, and you're good to go. So there are ways around that. Go.
Okay. Thank you very much, Mr. Bright and Mr. Toshiko, and every other person that made the class very interactive, and every other person present in this particular session. Our time is already fast spent. We are 7 minutes, exactly 7 minutes past. So I want to really appreciate everyone for our presence in this session. So thank you all for making it a day. I'm making it an evening. We meet again. Lightning sessions continues on Saturday. Don't forget we have our we have our the monthly session. Sorry, we have our monthly session. So it's going to be a very powerful one. Like I said from the beginning of this particular session, the tech space, yes, we claim that the tech space is evolving, it's gaining guns and everything, but who is actually dominating it? I can assure you, top 10% is just the top 10% is still not tech people yet. So even top 50, I can assure you. So it's time for techies to gain ground and actually dominate the space they call theirs. So we are going to be not just doing code, we are going to also, there is something called vertical scaling and horizontal scaling. So we are going to be scaling vertically now this time around. So see you on Saturday. It's going to be a great one. I wanted to ask a question about but our time is already fast spent. Thank you very much for joining. Have a wonderful night. God bless.